Hi, we have the AP Physics 1 past paper 2019. We are discussing the section free response questions. Now we have the question number 3 which carry the 12 points, in which question a projectile launcher consists of a spring with an attached plate as shown in a fig. When a spring is compressed, the plate can be held in a place by a pin any three position A, B and C. The pin is indicated A, B and C here. Is here show the uncompressed spring. Now, for example, fig 2 show the steel sphere is placed against the plate as shown in a fig, which is held by the pin at the position C. The sphere is launched upon release of the pin. A student hypothesis that spring constant of a spring inside the launcher has the same value for different compression distance. So that's the hypothesis of the student. The student planned to test the hypothesis by launching the sphere using the launcher. Now, first part of the question states the basic physics principle or law that students should use in designing an experiment to test the hypothesis. So, answer is the law or basic principle is conservation of mechanical energy. Mechanical energy consists of the kinetic energy and potential energy. Mean sum of kinetic and potential should remains constant. Okay, when spring is compressed, it is stored totally elastic potential energy when there is a no motion. When the pin is released, the elastic potential energy is converted entirely into kinetic energy. So if we neglect friction or air resistance, the mechanical energy is converted because the energy is entirely converted from potential to kinetic. So energy is conserved. Now, using second question, use the principle and law stated in part 1. Determine the expression of spring constant in terms of the quantities that can be obtained from measurement made with the equipments usually found in a school's physics laboratory. According to the conservation of mechanical energy, initial energy should be equal to final energy. So initially there is a potential energy, finally there is a kinetic energy, both 1 by 2 kx square plus 1 by 2 mv square. 1 by 2 should be cancelled, so k is equal to mv square x. So to find the value of k, we have to come to know from the three variable m, v and x. We have to measure the mass of the sphere or the block or velocity of the block and the position. Okay. Now these three things can be measured in school lab. Now next question is design an experimental procedure to test the hypothesis in which student uses the launcher to launch sphere. Assume equipment usually found in school laboratory is available. In the table below, list the quantities and associated symbol that would be measured in your experiment. Also list the equipment that could be used to measure quantity. You don't need to fill every row. If you need the additional row, you may add them to space just below the table. Now, first, this is an empty table given in a paper. There with the three headings: quantity to be measured, symbol to for the quantity, and equipment for the measurement. As we come to know, we have to measure the mass, velocity, and the position. So, for the mass of the sphere, we first of all we have to measure symbol is mass. So we use electronic balance to measure the mass. Now, for the distance or the compression distance, how much spring has been compressed, we use the symbol X, and meter stick or the ruler is used for the compression of to measure the compression of the spring. Now, horizontal distance and height. From these two quantities, we will be able to measure the velocity of the ball or the sphere. So, horizontal distance travel is stand for the R or the range. You can say meter stick or the measuring tape is used, and the launching height we use the meter stick. How much high the operator is placed. Now, describe overall procedure to be used to test hypothesis that the spring constant of the spring inside the launcher has the same value for different compression distance. Referring to the table, provide through details so that another student could replicate the experiment, including any step necessary to reduce experimental uncertainty. As needed, use the symbol defined in a table or include simple diagram of the setup. Now, Experimental procedure, first of all, use the electronic balance to measure the mass of the sphere. It is the simple measuring the distance of spring compression using the different position A, B, and C, and we have the value of position for XA, XB, and XC. Now place the launcher on a table so the sphere launches horizontally, measuring the height from the launcher of the floor. H is measured from the meter stick. Now release the pin, measure how far the sphere land from the table. That is the range or R. From both H and R, we can measure from H, we can measure the time of flight or T is equal to square root 2H by G. So H is the height, G is the constant, gravitational constant, time of flight is known. So velocity S is equal to Vt from, as we know that S is equal to Vt, we can calculate V. So V is equal to R by T. R is the distance covered by the sphere. T is the time. So we come to know from the velocity. So as we know that there is the three things required, M, V, and X. So we have experimentally can calculate three of them: mass, position, and the velocity. Okay. Now describe how experiment data could be analyzed to confirm or disconfirm the hypothesis that this spring constant of the spring inside the launcher has same value for different compression distance. Now we have to compare the value of K for the three different position XA, XB, XC. If all the K have approximately equal, then the hypothesis is confirmed. Experimental uncertainty, if there is a 5 to 10% difference considering the measurmental error in R and X, that could result in a difference, percentage difference. But that's the measuring error, not the value hypothesis against the hypothesis. If the spring constant is same for different compression, measuring the spring obey the Hooke's law linearly. Mean in this we have in the elastic region where the spring obey the Hooke's law. Okay. If the K value is different significantly, increase or decrease with the X hypothesis is disapproved. Spring may not ideal, perhaps non-linear large compression in this case. Okay. Another student uses the launcher to constructively launch several spheres of the half same diameter but different masses, one after another. Each sphere is launched from the position A. Consider each sphere as launch speed with speed of the sphere at the instant it loses the contact of the plate. On axis below, sketch the graph of launch speed as a function of sphere mass. This is the axis provided launch speed versus mass. Because the position is fixed, mean x is fixed, so energy store is fixed. So u is equal to kx. We come to know 1 by 2, 1 by 2 cancel, kx square by m is equal to v square. K is constant, x is constant, so we can say the velocity is inversely proportional to 1 over square root m. So from here we can say launch speed always decreases with the increases of mass sphere because it is the inversely square root value, so not linearly decrease, but it is concave shape decrease of the launching speed in initial when the launching mass is less, so launching speed is high. As the mass increases, launching speed decreases. So that's the solution result of his conclusion. So this is the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share with your friends. Okay, take care.